This lesson's all about exponents. So to start, I'm going to give you an example here, 2 to the 5th. An exponent is this tiny little number right here in the top right of what we call the base. This would be the base number, and this is the exponent. So the exponent represents the number of times the base is being multiplied by itself. So let's write that down. An exponent represents the number of times the base, this is the base right here, this 2 in this example, is multiplied by itself. Multiplied so up here at the top, x, when there's just one x, that is x to the first power. And we typically don't even write that exponent. It's invisible math. Right here we have y times y, so that is y to the second power. And we often also say squared for the second power. You can use those interchangeably. Z times z times z, so we're multiplying it by it 3 times. This is the third power. And sometimes you might hear it called cubed. A, there's 4 a's being multiplied together, so this is a to the 4th power. And surprise, surprise, b, there's 5, this is to the 5th power. One more thing that I want to note is the 0 power. So if we have m to the 0 power, that is always going to simplify down to 1. It means there's 0 m's that we're multiplying by each other, and that anything to the 0 power is always going to be 1. We use exponents to simplify expressions. So in this first example right here, 5 times 5 times 5 is going to be 5 cubed, or 5 to the 3rd power. In the next example, we have 4 times 4, and then we have an x. So this is going to be 4 squared times x. We're always going to put numbers and then variables. If there's more than one variable, we're going to put those variables in alphabetical order. It's not wrong if you flip-flop them, commutative property, but the mathematicians will tend to start with their numbers and then their variables in alphabetical order. Okay, so want you to try to write the rest of these in exponential form, then come back. Okay, here's what we have when we simplify with exponents all of these expressions. The next thing that we're going to do is we're going to focus on evaluating those exponents. So to evaluate an exponential expression, you are going to multiply to simplify your answer. For example, right here we have 6 squared, so this is 6 times 6, or 36. 2 to the 6th power, we're going to multiply 2 by itself 6 times. 1, 2, 3, 4, 5, 6, and that's going to give us 64. 10 to the 4th power is 10 times 10 times 10 times 10, 4 times, so that's 10,000. 9 to the 3rd power would be 9 times itself 3 times, or 729. Now we can use a calculator to help us evaluating these exponents. Oops. Okay, so better talk fast. My battery is about to die. So right here, 9, if we were plugging this into a calculator, there is a button on your calculator that looks like a up arrow. I call it a caret. That's what you're going to use to indicate that the next number you put in is the exponent. So if we type in 9 caret 3 and then enter, that will give us 729. Your calculator also has a squared button. We tend to square numbers often, so there's a button there for you. You don't have to do caret 2. You can do caret 2, but in this case, if you did 6 and then used the x squared button, you would get 36. Now I want you to try to expand these exponential expressions right here. I do want you to try to not use a calculator, but your calculator is there for you in this exercise. I just want you to get used to the fact of multiplying multiple times, not multiplying the base by the exponent, but multiplying that base number multiple times. Let me just say this right here. If we had 2 to the 5th power, please, please, please make sure that you are not multiplying 2 times 5. 2 to the 5th power is not 2 times 5. It is not 10. So that is why I want you to try to do these without your calculator. Okay, here are your answers with everything expanded out. Don't forget, anything to the 0 power gives you 1. Doesn't matter if it's a variable or a number, anything to the 0 power gives you 1.